Hi roboticists, finally today we are diving into a key topic for anyone looking to break into robotics. And in particular, we are going to install and configuring a robotic gripper as an end effector of our Universal Robot 5 and simulate it in Gazebo, complete with its controllers. So I walk you through exactly how to use a dedicated GitHub repository, showing you which files are essential, how they fit together, and how we will need to modify them for our needs and in order to simulate in Gazebo. Okay, um, before to start, make sure to subscribe to the channel, hit the notification bell if you want to make a transformation in a robotics engineer. And now let's get started. So the first things that we need to do is to look in GitHub for a robotic gripper repository. And if you type ROS2 GitHub robotic gripper, most likely you're gonna find this repository. This is the Picnic Robotic repository that is a very good company that, by the way, has designed and programmed MoveIt. So really a shout out to Picnic Robotics. And they have created this ROS2 Robotiq gripper that basically this is exactly what we need. Okay, so first of all, what we need to do is to go to the branch Humble, and then we need to clone this repository inside the source folder of our workspace. So I remember you that we have created in the previous video this workspace where we have the GitHub repository of the ROS2 description, the one for the Gazebo simulation, and then these are our custom package, Universal YouTube simulation that describes and simulates like spawning the Universal Robot 5 with a camera, and then this is the MoveIt configuration package. So we need to put the ROS2 Robotiq gripper here. So then what we need to do is to clone this repository, the ROS2 Robotiq gripper, inside our source folder as an external package. And so no. So let's clone it by typing git clone, make sure that the branch is gonna be humble. Okay, and then paste it here. Okay, there we go. We have this ROS2 Robotiq gripper. So we're gonna have the robotic controllers, robotic description, robotic driver, and the robotic hardware test. Okay, so first of all, let's try to build the package and see what's happened. Okay, so it seems that we are not able to compile because we miss this serial package. Okay, and this is affected by, I think, the robotic driver and the robotic hardware test. Okay, but since that for the moment we are simulating it in Gazebo, and then for the moment we are not gonna use an hardware. What we're gonna do is to just delete the robotic driver and then delete the robotic hardware test as well. Okay, so then let's type colcon build and see if now we are able to compile. Okay, there we go. We were able. Perfect. Okay, we are going to use the same approach that we have done with using the official repository of Universal Robot 5. I'm gonna put the link of that video in the top right corner. Okay, so let's check it out. It's very important. Now let's see what we have inside. So we have the robotic controllers. So this is okay, the file for the type of controller that we are going to use, but we are more interested in the part of the robotic description. So why that? Because we need to, let's say, since that it's a good practice to do not modify the official repository. We need to understand what is going to be the file that we can copy inside our custom package in order to make the modification that we need for our goal. Okay, and again, the goal is to simulate to attach first this gripper to our robot as an end effector, and then be able to simulate in Gazebo. So let's see if here we have everything we need. So we have this URDF. Okay, so most likely it's going to follow all the convention. So we are gonna have, so first of all we are gonna use this gripper QF85. Okay, so we have two types, QF85 and QF140. We're gonna use the QF85. Okay, so it seems that this file, again here, there's going to be the urdf.chakro, is, let's say, the father, okay? The one that we need to put inside the custom page that we need to modify this. Okay, and basically here what we're gonna need is to change this to tool 0 of our Universal Robot 5 and then adapt it. Okay, so this is using a macro robotic gripper, and this macro is here. So let's have a look inside here. Okay, so this is the macro. So we can see that we have this parameter here, and then here we are going to include. Okay, okay. So here we're going to include this file that is going to be ROS2 control that most likely it's containing, there we go, the ROS2 control tag. Okay, there we go. So this is the ROS2 control tag. Mm. Okay. Basically, before to copy this, let's have a strategy. We need, this is easy because we need to just update this to tool 0 and adapt it, adapt here, make try and error, okay? So now if we go to the macro, we have to consider something interesting here. You can see here that there's gonna be only sim ignition and sim Isaac. Okay, so it seems that this package is not designed to run in Gazebo. Okay, and in fact, if we go to the ROS2 control tag, what we're gonna see is only this one. So we see that if we are gonna use Sim Isaac, the Isaac from NVIDIA simulation, we will need to use this plugin. If we use Gazebo Ignition, we need to use this Gazebo plugin, this plugin, sorry. If we are not using any hardware and we are using only RVs, we need this plugin. And then if all of these are false, then it seems that it means that we are running into a real hardware, and then for that we need this plugin and all the package that we have cancelled. Okay, so what we will need to do is to copy this free file inside our our custom package, in particular inside the URDF, and then we need to update this free file in such a way that we can use the Gazebo simulation. Okay, so that's all for this introduction, and then let's modify our package. So first of all, let's create here a new uh, um, file, and let's call it Universal Robot 5, then camera, and then gripper dot urdf dot chakra. Okay, so there we go. Let's start to copy and paste everything here. Okay, so we have seen this. Remember, here, remember that we need to update this simulation controller, because we will need to add the robotic gripper controller. So bear in mind this, we will check it out later. Okay, so now what we can do here is to update here with exactly this father file, let's say, with the file that we have seen before. So Robotiq with this file. Okay, so let's do it. Okay, there we go. So I have copy what we had here. Okay, I have copied here at the end of this file that we have just created, and I have already adapted. In particular, what we are going to import the macro is this file, and we are gonna call robotic gripper macro. We need to create this one inside our package, and then here we need to use as a parent the tool 0 that belongs to our Universal Robot 5. Okay, so as I mentioned, we need to integrate a simulation gazebo part. So what we need to do is to add as an argument simulation gazebo. We have already done here, I think. There we go. So basically, we don't need to do it again. And then here, since that there's already an argument called sim gazebo, and we have set it up to true, then what we need to do is to update this part. There we go. So we have added the argument sim gazebo. Okay, but for adding this argument sim gazebo, it's meaning that we need to modify this macro, and this macro is contained inside this file that we are about to create. So here we need to add another file, and we need to call Robotiq, then gripper, then macro. Okay, so as I say, as you might know, you might be noticed that I'm using the same architecture. So I'm gonna have a file that is gonna be the father, that is gonna be this one, and in our case it's the father is the custom file that contains our robots our camera in a specific position, and then our gripper. So this is the father, and it's represented to here. Then the father relies on a certain macro of this particular components, and the macro is the one that we are about to create. And the macro is going to be this one, okay? And this macro is relying on the ROS2 control tag, or better, is relying on the file that contains the ROS2 control tag. Okay? So we need to update this. So let's copy and paste this file here. So copy and paste this file belonging to the official repository to here, and made the modification. Okay, there we go. So I have copied and adapted already. So this file contains the let's say the parameter that we need to set up for this macro, and here you can see that I have added sim gazebo to false. Don't worry if it's going to be false, because I remember you that if in the father file we have set up to true, there we go. So everything will be maintained in the children chakra file. Okay, and then here I have decided to put this file inside our folder, okay, because of course we need to modify it. And then here, this is another thing that I have added. So I've added the arguments that needs to be passed to this gripper that is contained in this file, sim gazebo, okay, because otherwise if you make a comparison between this file and the original one, there's not gonna be sim gazebo, right? Okay, so I hope that it's clear. And then this you can leave it like this because it's relying directly to the robotic description. Okay, so another thing, of course, if you clone this repository from the link that I'm gonna put in the description down below, of course you need to create the same workspace that I have. So you need to download this repository, and then this repository. Okay. Okay, so now we are about to do the next step. So we need to create this file that will contain our ROS2 controller. So now let's add another file, and let's call it robotic gripper.ros2 control.chakra. There we go. Again, here what we need to do is to copy this file and paste it with the adaptation that we need to use the simulation gazebo. There we go. This is the copy and paste with the modification. Again, here I have put this simulation gazebo argument as a parameter of this macro, otherwise it will not recognize. And then, most important thing, I have put this plugin. So if now simulation gazebo is true, and this is the case, we use this plugin, that there will not be this plugin without this modification. Okay, so now we have finished to modify the official repository file, and then this is the key important modification. So means that this is false, this is false, this is false, but then we are gonna use this one, simulation gazebo. Okay. Then another modification that I made is it's here in order to make the mimic properties work correctly. So if you make a comparison, uh, let's say that this chakra, this line has to be updated with the sim gazebo. Okay, meaning that if one of these is true, that we are using any type of simulation, then we need to use this parameter for the mimic. So meaning that again, this will be the driver, and then the right will mimic the behavior of the left by this multiplier. Okay, we have already discussed this mimic effect. Everything should be set up. Now, before to run into Gazebo simulation, what we need to do um, is to update the controllers here. Why that? Because if we are using this one, you can see that there's not the controller of the gripper. Okay, so again here, let's go inside this folder. So what we're gonna do is to use update this, and let's say Universal Robot 5 controllers and gripper. Okay, now in the config folder, let's add this Universal Robot 5 controllers dot YAML gripper. There we go. So here we need to copy this and paste it here. And then here we need to update the type of control, the name of the controller that we want to use here. So what is going to be this one? Let's go to the official repository, robotic description, config, there we go, robotic controller. What is the type of the controller? Is gonna be this one, robotic gripper controller. Okay, so position controllers, gripper action controllers. So let's use it here. There we go. SRC. And then we need to copy this one here. And there we go. So now we should have everything. Again here, before to run into simulation, it's a good practice to check in RVs. Okay, so let's create a, let's say another launch file that is gonna be view universal robot 5 with the camera with the gripper dot launch dot py. Okay, there we go. We have seen this type of launch file for only visualization in RVs is very similar to the one that we have created before. I just updated um, the name of the URDF file that we need to use. Okay, so let's build the package. Okay, source, and then let's run ROS2 launch, then universal robot YouTube simulation. We need to check view universal camera, then the gripper. Let's see what's happened. Okay, here is not URDF chakra, but is this one. Okay, let's check it again. Now it should work. Okay, there we go. This is a good sign. So again here, let's put base link, or better, let's put it the word that we can see that our robot is 0.8 upper with respect of the center of the frame of the word. Then let's add robot model and then of course the robotic description. There we go. So we have also, we were lucky because the position and the orientation of the base link of the robotic grip with respect of the tool 0, it's in a good position. And I remember you that we have set up it here, so this you will not need to change. This is very good. Then let's check if the joint are going correctly. Perfect. Okay, and then the other things works perfectly fine. Okay, center. What we're gonna do is to save, let's say, this RV's configuration. I save it as config universal robot 5 robotic. Let's save. Okay, and then we can close. Now let's use and load this RV's config here. Okay, there we go. It's working fine. Okay, now it's the time to create a launch file that spawns our robot, our camera, and our gripper in Gazebo. And we need to test also the controllers of the robots. Okay, and this is the crucial part. Okay, so let's close everything up here, and let's go to the launch file, and let's create another file, and let's call it spawn what a universal robot 5, a camera, and a gripper dot launch dot py. There we go. Okay, so before to create our launch file, I decided to change the name of the controller. Gripper position controller here, and gripper position controller. Okay, so here in the launch file we are going to spawn the joint trajectory controller for the universal robot 5 and the gripper position controller, and this is the type of the controller that our robot is using, and this is the type that our robotic gripper is using, and here the parameter that you need for your controllers. Okay, Okay, there we go. So this is our launch file we have seen in the last video. So what we have done is just simply to modify the name of the file of the controller file that we need to use as a parameter, and the name of the gripper, and the name, sorry, of the URDF chakra file. And we had to add other controllers. So the initial controller is going to be joint trajectory controller, but we have added here also the gripper control spawner. Okay, so this is using the executable spawner. So basically we have done exactly the same here, but with the gripper controllers. So this line is very important, and I would say that it's crucial to allow your robot to be controlled in Gazebo. Okay, so we have created our launch file. We are ready, but there's another important thing that allows you to spawn correctly the robotic gripper. Okay, so you need to tell to Gazebo where it needs to take all the geometry, shape, etc. This is something very similar that we have done with the camera. So what we need to do is to go inside the package here. Okay, and as here we need to tell, hey, where you're going to find the model of all the meshes, etc., of our robotic gripper in order to be spawned in Gazebo. Well, you need to go here. We are using a absolute path, and then you need to go inside the share folder of the robotic description package. Okay, now we should have everything to test. So let's run a colcon build, and then run the simulation. Okay, there we go. So we have our Universal Robot 5 with our robotic gripper that is correctly spawned. Okay, and then if you see here, you see that it's starting to the close position, but it's okay. So now let's check first of all what are the node available. ROS2, um, ROS2 node list. Okay, we have the controller manager, the gripper position controller as a node. Okay, but I remember you that our controllers for the gripper is gonna be an action controller. Okay, so if we want to command, at least for now, as in the terminal, the robotic gripper, we need to check the action that are available. So ROS2 action list, and there we go. There's gonna be the gripper position controller command, gripper command. Okay, then you can to ask to Gazebo to check what are all the controllers that are running at the moment. So ROS2 control, then it's gonna be list of controllers. Let's check. And then here we have three controllers. We have the joystick broadcaster, the joint trajectory controller, and the position controller. Okay, so now let's ask um, the the gripper to go to open the gripper. Okay, well, we need to send an action command, an action goal. How to do? So what we can do from the terminal is ROS2 action send goals to what? Let's check what we have available. Send goal to the gripper position gripper, then we need to type the type of controller that is going to be the type of message, sorry, that is going to be control messages action, and then here the command. So we are asking to the gripper to go in the 0 position, that is the open. Let's check. There we go. So we are able now to control our robotic gripper in Gazebo by sending a command via command line through the terminal. Okay, and then we have done it by taking the official repository designed from Picnic Robotics somewhere else, and then we have adapted in order to make it work with Gazebo. We have updated all the file, we have updated the arguments, and we have updated the plugin that we really need to simulate a robotic gripper in Gazebo. Then let's ask to go, I don't know, to 0.4. Okay, so it's closing. So then feel free to try what is gonna be. I think that the maximum is gonna be 0.7. Okay, this is almost close. Okay, but then you can see that RVs are interfering correctly with the Gazebo. And then let's try to open again. Okay, so that's all for today. I hope that you enjoyed this video and you have go forward in your pathway to become a robotic engineer. Okay, if you want to have a deep dive in the robotic software engineering domain, or in general robotic engineering, check out the masterclass that is under construction. I'm gonna put the link in the description down below with the coupon, because it's gonna be a pre-selling phase. The course is under construction. The style of the lection will be similar to YouTube, but it will be more in depth. So basically here we are using sometimes some copy and paste to make this video shorter, but in the video I'm gonna explain you line by line what we are doing, why we are doing, and how we are doing. Okay, so again, thanks for your attention, and as always, keep learning robotics with Ross.